All right, guys. Today we are going to look at electric field. Okay. So, but before we start studying electric field, we'll be able to define field and the types of field that we have. Okay. So, what is field? We say field is a region or space around a source where the influence of the source can be felt. Or field is a region or space under the influence of some physical agency, such as electric field, magnetic field, gravitational field. When you talk about gravitational field, you are talking about field around a mass. When you talk about electric field, you are talking about field around a charge. When you are talking about magnetic field, you are talking about field around a magnet. Okay, so in just few steps, I'm going to summarize this topic. This topic is for students in SS3 that are writing their WAEC, NECO, JAM, NAPTEP, okay, or for year one students in the university. So now we define electric field. We say electric field is a region or space around a charge where the influence of the charge can be felt. Electric field is a region or space around a charge where the influence of the charge can be felt. Now, we have two types of charges. We have positive charge and we have negative charge. Now, the field around this charge is what we call electric field. Now, for a positive charge, the field moves outward. For a negative charge, the field moves inward. So, following law of electric lines of force, we say that the field starts from positives and end in negative. The field starts from positive and end in negative. And then another law of electric line of force states that like charges will repel while unlike charges will attract. Let me use diagram to demonstrate it. We have a positive charge here and we have a negative charge here. Or let me use the one we have done already. We have a positive charge. We have a negative charge. Now this field will move this way. So we move. The arrow indicating the direction of the field. Electric lines of force do not cross each other and they are evenly spaced. So for positive charge, it will be moving outward. For negative charge, it will be moving inward. So the law says that the line of force starts from positive and ends in negative. Okay, now having said that, let's represent unlike charges. If we have positive, the field will move this way, will move this way. At this point, since it is positive, it will be moving outward. This point is called neutral point. So there is force of repulsion here. There is force of repulsion. Here, force of attraction is taking place. Here, force of repulsion is taking place. Okay? So that is it. Now, a man called Charles Coulomb did some work in this field and he propounded a law that says that the force of attraction or repulsion in an electric field is directly proportional to the product of the charges and inversely proportional to the square of their distance of separation or their distance apart. He says that the force of attraction or repulsion in an electric field is directly proportional to the product of the charges and inversely proportional to the square of their distance of separation. So I will write it here, Coulomb's law. That is in mathematical form. Coulomb's law in mathematics terms, Coulomb's law, he said that this force is directly proportional to the product of the charges Q1, Q2. I call that equation 1. And then that this same force is directly proportional to the, is inversely proportional to the square of their distance of separation. That this force is directly proportional to the product of the charges and it is inversely proportional to the square of their distance of separation. So I can call that equation 2. Now, combining this equation 1 and 2, we are going to have that this is directly proportional to Q1, Q2, and it is inversely proportional to the square of the distance of separation. So we can call that equation 3. Okay, if we remove this sign of proportionality, we introduce a constant, and that constant becomes K, so that we have K, Q1, Q2 is inversely proportional to the square of their distance of separation. I can call that equation 3, where K is a proportionality constant, which is equal to 1 all over 4 pi epsilon naught, epsilon naught. 1 all over, the value of this K equals to 1 all over 4 pi epsilon naught. And this is also equal to 9.0 times 10 raised to power 9 Newton meter square per column square. So this is the size of this constant K, or 1 all over 4 pi epsilon naught. All right, if that is the case, I can change, since K is equal to this, I can change this equation 3 to this. I can transform it to this. So equation 3, therefore, now becomes F equal to Q1, Q2 all over 4 pi epsilon naught R squared. So we can call that equation 4. So this is the force of attraction or repulsion between two charges. All right, so you take note of that. Then we move into another subheading, which is called electric field or electric field intensity. Electric field strength, field strength, or intensity. Electric field strength or electric field intensity. We use E to represent this electric field strength or intensity. Okay? Now, what is electric field strength? Electric field strength is the force per unit charge at a particular point. Is the force per unit charge at any point, at a particular point. Okay? So, F, that electric field strength or intensity E is F over Q. And since this is in Newton, this is in Coulomb, so the unit becomes Newton per Coulomb. Is the unit of electric field strength or electric field intensity. Okay, so we can call this equation 5. Moving further to derive other equation for this electric field intensity, since we have said that force, electric field force of repulsion or attraction is given by Q1, Q2 all over 4 pi epsilon naught R squared. Now, I want to do something here. So, permit me to change this equation, transform it to this, so that we can have Q all over 4 pi epsilon naught R squared. Because here we'll be talking about point charge and a test charge. It is a test charge that is used to test the intensity of this point charge. Okay, let me use diagram to explain it a bit. We have a point charge situated in, we have a point charge situated in a vacuum. Okay, and this point charge is positively charged. And then we have a test charge somewhere here at this point A.